Hello and welcome to the 10.3 notes. So here we go. We got 6 more theorems to work on, and then the rest are just some practice problems. So here we go. Theorem 10.11, which says this. It says if you've got an angle where the vertex is on the circle, like that, or you think about it like you have a tangent and then something like that, the angle measure will be half of whatever this arc is. So if this is like a 100-degree arc, then that makes this angle 50, and so forth and so on. Well, that was a bad example because that's not a 50-degree angle. Let's call this a 200-degree arc. That would make this a 100-degree angle. That'd be more like it. It would make this a 100-degree angle, and then if this was 200, then this arc here would be 160, which would make this an 80-degree angle. And what's 100 plus 80? 180 for the nice linear pair right here. Alright, so that's how that works. The angle is half of the arc. It's like an inscribed angle. If you remember Theorem 10.7, the angle is half of the arc. Down here, this one is interesting because it has it relates vertical angles, kind of. It's like this and this. So it turns out that angle 1 is the average of these two arcs. Alright, so it's like they're vertical arcs almost. They're across from each other. And there's an interesting proof. I'm not going to get into that. But these are all really fun to prove. If you're bored, try and prove some of these theorems. But it turns out that the angle 1 is the average of these like vertical arcs, and angle 2 is the average of A and B. You can see that in the formula. A plus B divided by 2 is the measure of angle 2. Alright, so A plus B divided by 2 is that one. Theorem 10.13 has like 3 possible scenarios. It's an angle outside of a circle. This is 2 secant lines. This is a secant line and a tangent line, and this is 2 tangent lines. But still, the angle, the deal here is that the angle is outside of the circle. Again, interesting proof. If this was class, we'd probably go over it, but it is what it is. It turns out that to find angle 1, you take the large arc that's inscribed minus the small arc. So think about it as, and then you do half. That's how I do it, large minus small, 1/2 large minus small. So to find angle 1, you take x and subtract y and take it and do half. And to find 1 here, you do the entire, that minus y, x minus y times a half. And that's how you do that. Theorem 10.14 looks a lot like Theorem 10.12. The difference is Theorem 10.12 is about the angles and the arcs, and Theorem 10.14 is about the lengths of these segments. And it turns out that if you take 2 chords, A times B ends up being the same as x times y. So piece A times piece B equals piece X times piece Y. A times B equals X times Y. Theorem 10.15, now this looks a lot like this. The difference is this is about the angles and the arcs, and this is about the lengths of these segments. And it turns out, here's how I like to think about it, outer times inner. That's the way you get these wrong. Outer times whole. That's how we think about this. What I mean by that is the equations that work here is that if you take the outer part times the whole part. So that would be A times A plus B, that's outer, times entire length. Ends up being outer times the entire length. Alright, so A times A plus B equals X times X plus Y. That's what that ends up being. And then lastly, Theorem 1016 is basically the same as this one, and you can still think of it as outer times whole, but in this case the outer part is the same as the whole part, so you have A times A, which is A squared, so you have A times A is equal to X times X plus Y. A times A, X, X plus Y. Now these are your theorems. You get to use these theorems. You just have to be able to visually recognize what theorem you need to use to solve the problem. Alright, so if you see an angle outside of a circle, you know that if you're dealing with the angle itself, you're up here at 1013. If you're dealing with the lengths of the segments here, you're down at theorem 1015. If you see chords inside, you're at one of these theorems. So it's like you have to visualize and then figure out what theorem you're going to use. Alright, so let's do some examples. Example 1 here, we have got an angle outside of a circle, and we're going to apply basically this right here. It's the same idea. We're going to do 1/2 large minus small. So the angle, we'll call it x, angle x. That's typically what mathematicians do. So the measure of angle x is 1/2 large minus small is the way I like to think about this theorem. 1/2 large minus small. So the large arc, if this arc's 100, this has got to be 260, because 260 plus 100 is 360. So that's 260 minus 100, like that. So that would be 160, and half of 160 ends up being 80. That's an 80-degree angle. It has to be an 80-degree angle. It's kind of magic, but there is proof to it, and these are pretty cool proofs if you have the time to do them. Same idea as this one. We got an angle outside. The angle is 1/2 large minus small. In this case, here's our x right here, so that's going to change things just a little bit. So it's going to be, in this case, 45 equals 1/2 large minus small. So here we know that the large piece is 141. 141, I can write that better. The small piece is our x. So in this case, the x goes there. Alright, to get rid of the 1/2, I'm going to multiply the 2 over. Alright, so you can think about it, 141 minus whatever, but bring the 141 over, and you get negative 51 equals negative x, and x equals 51 when you work that out. Alright, number 3, again, excuse me, this one is going to get pretty complicated actually, so I'm going to turn the page over and do it on that, but we'll get started here. This one is a beast. Takes these to the next level for sure. It's the same idea as number 1. We got the angle outside, so we're going to start with alright. Let's see here. Let's do it right here. I'll keep going right here. Here we go. Okay. I'm going to use brackets because we're going to get some parentheses going on here. So what is the large arc here? It's this. That's the large arc. Let's come back to that. I'll put in parentheses. And what is the small part? The small part's given to us. The small arc here is 61x minus 2. Alright, so I've got 60. The angle is 1/2 large minus small, the large part of the arc minus the small part of the arc. And now I just got to figure out what is this large arc. Well, if this is, whatever this is going to be 360 minus that. So actually you do 360 minus 61x minus 2. I'm using parentheses pretty liberally here. So that's large minus small. And here we go. Let's start by getting rid of this 2. So you got 120. So that takes that out. And now I'm going to go through and take care of my negatives. Now this negative distributes like this. So you got 360 minus 61x plus 2. And that's where a lot of people get wrong here, is they don't distribute this negative. Same thing here, this negative distributes like that, and now it's basic algebra. Let's keep going. We can combine these. 364, and we can combine these. And now it's, again, basic algebra from here. Move over the 364. And this is going to work out very nicely because that divides over and x is 2. That worked out nice. So anyway, x is 2 for this one. Let's keep working. Number 4, we go to a different theorem. Number 4, we've got some chords, and they're intersecting in here. And so we're either going to be at this one or this one. And what are we looking for? We're working with the angles. So we're up here at Theorem 1012, which says that the angle is the average of the vertical arcs. So this angle is the average of that and that. They're like arcs that are across from each other. So think about it like this. So 117, the angle, is the average. Call this our x. Alright, so 117 times 2 is 234. And subtract 54, you get 180. Oh, look at that. Turns out that this was a semicircle. Kind of looks that way. That's half and that's half. Turns out to be 180 degrees. Alright, number 5. Looks like number 4, kinda. And it is. Well, it's the same theorem. We're going to say that the angle is the average of those two. So in this case, our angle is 24x plus 4. And it's the average of 55 and 193. So to add them up and divide by 2, that's the average of those two. And pretty basic algebra here. We're going to take this 2, we're going to multiply it over. So we got to multiply everything by 2. That would turn this into 48x plus 8. Like that. We can go ahead and add these together and take over the 8. So 55 plus 193, and then subtract the 8. You end up getting 240 here, and hopefully that divides out evenly, and it does. X equals 5 when you divide out the 48. Alright, number 6. This one's going to be different. Looks like we've got a tangent and we've got a secant, and And that's going to be like Theorem 1016, where we got a tangent and a secant, which says outer times whole. Outer times whole equals outer times whole. So in this scenario, we're going to do outer times whole, or 30 squared. 30 times 30 equals outer part times the whole length of this. So 18 plus x. Not 18 times x, 18 plus x. Alright, so 30 times 30 is 900. Get 900 there. And then here we're going to distribute. So that's 18 times 18, which is 324. And then 18 times x. Like that. Subtract the 324 to get 576. And divide the 18 to get 32. Alright, still going. Number 7, we've got, looks a lot like number 5. You've got two lines, two chords here. Except the difference is, for number 7, you're dealing with the lengths of the chord. So we're going to look at Theorem 1014. A times B equals x times y. So same idea here. We're going to do 8 times 9 equals x plus 4, minus 4 times x plus 2. Alright, there's the algebra. This side is just 72, but this side you have to FOIL. So you got to do x times x, x times 2, negative 4 times x, negative 4 times 2. So there we have it. Alright. Oh, this is a quadratic. And we know how to solve a quadratic. To solve a quadratic, you must bring the 72 over. So we're going to have x squared. And this is going to turn out to be minus 2x. And when you bring the 72 over, negative 8 minus 72 is negative 80. Alright, so now we're looking at, we got to find two numbers that multiply to 80 and can make 2. It's got to be 8 and 10. 8 and 10. Specifically negative 10 and positive 8. Negative 10 and positive 8 when you combine make negative 2. Negative 10 and positive 8 when you multiply make negative 80. So the answer that makes this 0 is 10 minus 10 is 0. And negative 8 minus negative 8 plus 8 is 0. So those are your answers. Can you have a length of, if I plug in negative 8, negative 8 plus 2 is negative 6. You can't have, negative 8 is not one of the ones. But 10 should work, and we can test it. 10 plus 2 is 12. 10 minus 4 is 6. What's 8 times 9? 72. What's 6 times 12? 72. 10 was the answer for our values. And the last problem here. This is the one where we're going to do outer times whole. So in our case, this is going to be x minus 3 times the entire length. Now I'm going to combine these two to get the entire length of this. So that would be 2x. And then if I combine 1 and negative 3, that would be minus 2. Alright, so it's x minus 3 times the entire length. To get the entire length, I had to combine those two. The other side's easy. We're going to do 6 outer times the entire length, and if I combine 15 and 6, I get 21. Alright, so there we have it. And if we're going to FOIL, so that would be x times 2x, so that's 2x squared minus 2x minus 6x plus 6, and then 6 times 21 is 126.